We now have our reducer properly set up for catching our actions type. So now we just have to update our state object with the new text that the user just typed in there. So remember, the entire goal here, like the overarching theme, is we are using the reducer to store the current value of the text input. So by default it is an empty string, but eventually a user is going to start typing in their email, and we're going to catch that right here on this line when action comes across our reducer. Now, as we have learned, whatever value we return from this reducer will end up as our application state, right? So we need to somehow update our state object and then return it from this line right here. So eventually we're going to end up with something that says return state or something like that, right? The question is, how do we update our state object? How do we do it? So first, let me show you a little diagram. It's going to help you understand what's kind of going on behind the scenes, like what Redux is actually doing. So this is what Redux is actually doing. Whenever we call an action creator, or for a better piece of terminology, dispatch an action, we take our slice of state, like the state that this single reducer, like this auth reducer, that's what this is supposed to be right here. We take this slice of state that the reducer last published or last produced, we throw it into the reducer along with the action, and then out we get this hey, new fantastic piece of state. Okay, so some piece of state is going in, new piece of state is coming out. That's it, okay? Now, there's one very interesting little detail in here. Okay, so this is a expanded diagram, still the same diagram on the top half. I just added on a couple boxes on the bottom. After our reducer runs, Redux looks at the old value of state and the new one. So I'm talking about this slice of state up here, this initial argument to the reducer, and the return value. It looks at the two of them. So new state right here, as I have written, is this new slice of state right here. Old state would be the old slice of state at the top left up here. And it says, is the new state equal to the old state? And specifically with a triple equal sign right there, okay? Specifically triple equals. If the result of that is yes, if the two of them are equal, then Redux assumes, hey, it's the same object. I guess nothing happened. No data changed, nothing happened. I don't have to worry about telling any components about what is going on here. On the flip side, if the equality fails, so if they are not equal, and I probably got the colors here a little bit backwards with the green and red, but whatever. So if they are not equal, then Redux says, aha, something must have changed. This is a new object. They are not identical. They are not equal. Something must have changed. That means the user, or excuse me, the developer intended there to be some new piece of state. I must take this new state and send it off to all the different components out there in the wild. Now the real key here is this triple equals comparison here in the middle. Okay, that's the whole key to this. So you might be thinking to yourself, oh yeah, Redux is going to compare these two objects. Hey, if we just put a new value somewhere on that object, it's not the same object anymore, right? Well, maybe not quite. And this is where we start to really go down the rabbit hole a little bit, okay? This is a little bit of pseudocode here that I'm trying to make a singular point, okay, just one point here. Let's say that I take some variable declaration. So I'm saying const state equals new object, or empty object. And then I say const new state equals state. So now I have the variable state, which looks at an object, and I have the variable new state, which also looks at the very same object. They're both pointing at this object right here. And now I say new state.color equals red. Okay? So I am setting a property on this object right here of color equals red. Then if I said new state equals state, what would I expect to get back? Right, I have changed the object that new state is looking at. What would I expect to get back there? Well, the answer to that is by really understanding how JavaScript compares equality between variables with this triple equal sign. So it's one or two more slides here. Just bear with me for a second. So this is on the left-hand side, same diagram. On the right-hand side, it's a diagram of kind of what's going on with JavaScript behind the scenes. So with the first line, we say const state is an empty object. We have now created an object in memory, on your device's RAM. We have an object in memory, and we have a pointer that is or a variable essentially, that is looking at that object. We're saying, hey, here's an object in memory, and I have a reference of state to that object. Then with the second line here, when we say new state equals state, we are not making a copy of the object. That is the super mind-boggling part about JavaScript that you really got to wrap your head around. We are not creating a new object here. The same object is sitting in memory. There's only one, but both state and new state are looking at that object. Finally, or I shouldn't say finally, but next, when we say new state.color equals red, we still only have one object, and we did not create like a new mystery object. Like nothing got copied out for us here. There is still just a singular object. So new state is looking at the object with property color and a value of red, and now state is still looking at the exact same object. So at the bottom, at the very last step here, when we say, hey, is state triple equals to new state? What is happening behind the scenes is JavaScript is saying, I have 2 pointers, like two pointers here that are pointing at some values. Are they both looking at the exact same object in memory? And the answer is unequivocally yes. Okay, unequivocally yes. So the entire point of this lecture, the entire thing I'm trying to say here, is inside of our reducer. When we try to update our state object with this email property, when we take whatever text that the user just entered that's going to come in from this action right here, and we try to update that state object, if we do not modify it, if we do not update it in the correct fashion, we are not going to, Redux is going to think, hey, nothing actually changed. It's going to think, no change actually occurred. Oh, we don't need to look at this just yet, sorry. Nothing actually occurred. So we need to figure out a way to make sure that Redux understands that, hey, we updated our state object, but something did change here. Like something actually did change. So that's what our big goal here is. We're going to take care of that in the next section, but the very last part of like this lecture that I really want to convey to you is I should probably bookmark this file right here. So this is a part of the Redux library. So on GitHub, React.js, Redux, and I'm in the source for the combine reducers call. So combine reducers JS. I should really bookmark this thing because I end up sending it out just all the time to try to convey this whole topic of how Redux compares equality. So I'm going to scroll down to the very bottom. Really just all I want you to see here is like visual proof of what I'm trying to convey here, and that is you have to make a new object, or you have to make sure that Redux understands that you changed the value. So this is like the real magic line right here, like these two right here. This code up here is what takes the action that you have dispatched and sends it off to all the different reducers inside your application. After each reducer runs, has changed is declared as did the value actually change? Like, is the thing still here? Has the value actually changed? The piece of state out of the reducer, has it actually changed? And then eventually a comparison is made and said, hey, has anything actually changed? If it has, return the next state, otherwise return the old state. So this is like kind of the root of Redux where this comparison is being made. Looking at this stuff isn't super necessary for understanding the idea here. I just want to point this out if you have any interest in kind of diving into the source a little bit more. You can always check out that combine reducers call. Okay, so let's take a quick break, come back in the next section, figure out how we actually implement all this knowledge about how Redux expects us to see our state object changed.